All right. Hi, everybody. Tomorrow we're going to be starting a unit on exponential functions. So today I thought we'd just start off with working with some properties of exponents and helping us fill out tables of values. Because in order to graph exponential functions, we need to be able to do tables of values. And you'll kind of see how it's going to fit in with what we've been talking about with AH and K starting on Monday. So let's start off with kind of a basic example. I'll go through this with you guys, and then I'll have you pause the video and try the next one, and then we'll kind of continue on working through some examples together. So without the use of the calculator, let's evaluate these expressions. And we want to leave our answers in exact form, so we don't want any decimals here. So let's look at that 2 to the third first. So properties of exponents, hopefully you know that that just really means that we're multiplying 2 times 2 times 2. So 2 multiplied 3 times gives us 8. 2 squared, pretty simple, straightforward. That should be a 4. 2 to the first power is 2. And then 2 to the 0 power, that was a property that we had talked about. Anything to the 0 power is always just 1. All right, so let's look at the bottom problems here. So 2 to the negative 1, 2 to the negative 2, and 2 to the negative 3. So now our exponents are negative, but that's okay because when we were talking about properties of exponents, we learned how to work with negative exponents, what to do with them. So this 2 to the negative 1, I'm going to imagine this as being a fraction as 2 to the negative 1 over 1. So to make that exponent positive, I'm going to go ahead and pull that to the denominator. So that's going to become 1 over 2 to the positive 1 when I move it. And that just becomes 1 over 2, because 2 to the 1 is just 2. I'm going to go ahead and do that for the next one too. So 2 to the negative 2, technically over 1, pull it down to the bottom. That's going to become 1 over 2 to the positive 2 power. And I'm going to simplify that as being 1 over 2 squared is 4. And then 2 to the negative third, again, same idea here, pull that down to the denominator. That's going to become 1 over 2 to the positive 3, which is 1 over 2 to the third is 8. All right, so now that we've done this work, how does that relate to this table down below? Well, it's asking us to complete the table of values for 2 raised to the x power. If you notice that in all these examples, our base was 2. So this is telling us to take this base of 2 and raise it to some x power. Well, what is that x power? That's going to be these numbers across the top. So this negative 3 is really asking us to take our base of 2 and raise it to the negative third power. Well, guess what? We already did that work up here. 2 to the negative third is 1/8. I'm going to continue across the chart here. So 2 raised to the x power, so our x is negative 2. That's asking us to evaluate 2 to the negative 2. Well, we figured that was 1 over 4. Over here, 2 to the negative first power. Over here, we said was 1/2. 2 to the 0 power we said was 1. 2 to the first is 2. 2 squared is 4. And then 2 to the third is 8. So I'm going to have you pause the video and try the example down at the bottom of the page, and I will meet you on the next page. All right, so you'll notice that this next example looks definitely different than the front ones, because on the front examples, our bases were just integers. Now our base is actually a fraction. That's okay. We know how to work with fractions with exponents. So remember that when we have a fraction raised to some exponent, the exponent needs to get to both parts of the fraction. So I'm going to rewrite this 1/2 raised to the third power as 1 to the third power in the numerator over 2 to the third power in the denominator. And I'm going to go ahead and evaluate those each separately. So 1 to the third up top is 1, 2 to the third down below is 8. So 1/2 raised to the third power is 1/8. I'm going to go ahead and do that for each one of these. So our next example is 1/2 raised to the second power. So that's 1 squared over 2 squared. 1 squared is 1, 2 squared is 4, so 1/4. Next one, 1/2 raised to the first, 1 to the first over 2 to the first, leaves me with a 1/2. And I can do the same thing with the 0 power over here. So 1 to the 0 over 2 to the 0. 1 to the 0 is 1, and guess what? 2 to the 0 is also 1. So 1 over 1 simplifies to 1. These down below are going to be a little bit different again because now we have negative exponents, but our initial steps are still going to be the same. I want to go ahead and make sure that -1 power gets to both pieces. So 1 to the -1 over 2 to the -1. And we know how to make our exponents positive. So I'm actually going to flip-flop these, and I'm going to bring the 2 up top. But when I bring it up top, the exponent's going to become a +1. Bring the 1 down below. Again, the exponent's going to become positive. So 2 to the first over 1 to the first is really just 2 over 1. So 2. Go ahead and do the same thing with the next one. So 1 to the -2 power over 2 to the -2 power. I'm going to go ahead and flip-flop those. That's going to become 2 to the +2 up top, 1 to the +2 down below. 2 squared over 1 leaves us with a 4. And I'll go ahead and do the last one as well. So 1 to the -3rd power over 2 to the -3rd power. Go ahead, flip-flop those. So 2 to the +3rd over 1 to the +3rd leaves us with 8 over 1, which is just 8. So same idea with the bottom here. To fill in the table of values, it's asking us to take this base of 1/2 that we worked with up there and raise it to some x power. Well, what's the x power? -3, -2, -1, 0, 1, 2, and 3. So this is asking me to do 1/2 raised to the -3rd power, which we just figured out was 8. 1/2 raised to the -2nd power is 4. 1/2 raised to the -1st power is 2. 1/2 raised to the 0 is 1. 1/2 raised to the 1 is 1/2. And we said 1/2 raised to the 2nd power was 1/4. And then finally, 1/2 raised to the 3rd power was 1/8. So again, those are just the values that we figured out above. I'm just kind of putting them together and organizing them nicely in the chart. All right, so go ahead and pause the video and try the examples with the base of 3 over 2, see what you come up with. All right, so the next problems look a little bit more complicated. So we've got a couple of more operations going on in here, but we're just going to want to follow our order of operations to help us simplify these expressions. So our first order of operation tells us to do parentheses. Well, I don't see parentheses anywhere here. So then I'm noticing that I've got exponent values. And I'm going to simplify the exponent values before I do any of this work on the outside. So over here, I just want to go ahead and do out that 3 plus 1. So I'm going to pull over the 3 times 2. And the exponent up here, 3 plus 1, is going to give me an exponent of 4. And then I'm going to continue to evaluate the term that has the exponent on it. So this is going to become 3 times 2 to the 4th is 16. So when I do 3 times 16, that gives me an answer of 48. And I'm going to do the same process all the way across here. So simplify my exponent. So it's going to become 3 times 2. 2 plus 1 is 3. So 3 times 2 to the 3rd. Evaluate 2 to the 3rd. So pull over that 3 times 2 to the 3rd is 8. So 3 times 8 gives me 24. Over here, same idea. 3 times 2. This time the exponent is going to become 2. Evaluate that. So that's going to become 3 times 4, which gives us the 12. Last one up on the top. 3 times 2 to the 0 plus 1 is just 1. Evaluate that 2 to the 1st. So that's just 3 times 2, which is going to leave us with a 6. All right, down below, you'll notice that our process is going to be a little bit different because now I'm working with some negative values. So same idea, I'm still following the same process. I want to evaluate the exponent first. So 3 times 2 to the -1 plus 1 is 0. This becomes actually pretty easy because 2 to the 0 just ends up being 1. So I really just end up multiplying 3 times 1, which is just a 3. Next one, 3 times 2 to the -2 plus 1. So 3 times 2. -2 plus 1 is -1. So I'm going to need to do a little bit of work with this. It's not as kind of straightforward as the examples above where our exponent was positive. I'm going to pull over the 3, and I'm going to rewrite this 2 to the -1 power. Because remember, this is really just a fraction over 1. And to make that exponent positive, I'm going to have to bring it down to the denominator. So that's going to be multiplying 3 times 1 over 2 to the positive first power. So I'm going to make both of these into a fraction. That becomes 3 to the 1 times 1 over 2 to the first is really just the same thing as saying 1/2. So 3 over 1 times 1 over 2 leaves me with a 3 over 2. And I'm going to leave my answer in fractional form like the directions are asking me up at the top. So let's look at one more. So evaluate the exponent first. So 3 times 2 to the negative 3 plus 1 is negative 2. I'm going to evaluate this piece first. So I'll rewrite this as 3 times 1 over 2 squared, because again, think about that as being a fraction over 1. To make it positive, you have to move it down. And then I'm going to go ahead and make this into a fraction. So I'm going to make that into 3 over 1 times 1 over 2 squared leaves me with 1 over 4. So when I multiply 3 over 1 times 1 over 4, that gives me a 3 over 4. All right, so now it's telling us to complete a table of values for the function 3 times 2 to the x plus 1. Well, 3 times 2, if you'll notice, happened in every single problem that we just did. And the plus 1 also happened in every single problem that we just did. The only number that was changing was that first number, the 3, the 2, the 1, the 0, etc. down at the bottom. So it's asking us with this function, when we plug in a negative 3 for our x value, it's asking us to evaluate 3 times 2 to the negative 3 plus 1. Well, we just did that work up here. We said that that was 3 over 4. Here, it's asking us to do 3 times 2 to the negative 2 plus 1. Well, that was the one that we just did before that, so that was 3 over 2. This is asking us to do 3 times 2 to the negative 1 plus 1. That was the problem we did over here. We said that was 3. 3 times 2 to the 0 plus 1 was the one that we did up here, so that was 6. 3 times 2 to the 1 plus 1, we said was 12. 3 times 2 to the 2 plus 1 was the second problem we did. We said that was 24. And then 3 times 2 to the 3 plus 1 was the first one that we evaluated up here, which was 48. So go ahead and try the next example. Put the video on pause, and I will see you guys on the next page. All right, so our last problem here that I'll do with you, and then I'll have you try that one at the bottom, is still a little bit more complicated than the last one, because now we don't only just have that 3 times 2 to the exponent, but you'll notice in every single problem, now we're subtracting 4, minus 4, minus 4, minus 4. So our process is going to be a little bit different, but we can still tackle this. So let's go ahead and, again, work with our order of operations. So we want to go ahead and evaluate the exponent first. So I'm going to simplify this to be 3 times 2 to the 3 plus 1, which is 4, minus 4. So be careful here. What I want to do first is, again, I still want to evaluate this base with the exponent on it, but then I'm going to follow my other order operation that says I need to multiply before I add or subtract. So I'm going to rewrite this as, in parentheses, 3 times 2 to the 4th is 16. I'm going to close my parentheses right here to remind myself that I need to do this multiplication first. And then I'm going to go ahead and subtract 4 from that. So 3 times 16 gives me 48. And then I'm going to go ahead and subtract the 4 from that. So 48 minus 4 should give me a 44. All right, let's look at the next one. So 3 times 2 to the 2 plus 1 minus 4. So I'm going to go ahead and evaluate that exponent first. So 3 times 2 to the 2 plus 1 is 3 minus 4. So I'm going to go ahead and do this piece first. I'm going to open up a set of parentheses, bring the 3 over, times 2 to the 3rd, which is 8. Close my parentheses to remind myself to do that multiplication first, and then minus 4. So 3 times 8 gives me 24. Minus 4 leaves me with a 20. Go down to the next bottom left one. So 3 times 2 to the 1 plus 1 minus 4. So this is going to become 3 times 2 to the 1 plus 1 is 2 minus 4. Open up myself a set of parentheses. So 3 times, evaluate this, 2 squared is 4. And then pull over that minus 4. So 3 times 4 is 12. Minus 4 leaves me with 8. Do the same thing over here. So 3 times 2, 0 plus 1 gives me a 1, minus 4, open up my set of parentheses. So 3 times 2 to the first is just a 2, minus 4, leaves me with 6 minus 4, which is 2. All right, moving down. So 3 times 2 to the negative 1 plus 1 minus 4 leaves me 3 times 2. Negative 1 plus 1 gives me a 0, minus 4. So I'll go ahead and evaluate that piece first, open up my set of parentheses here. So 3 times 2 to the 0 is actually just 1. Close my parentheses, minus 4. So 3 times 1 leaves me with a 3, minus 4 gives me a negative 1. All right, let's work with the next couple. So these are going to be a little bit different. So now we want to do 3 times 2 to the negative 2 plus 1. So I'll do my negative 2 plus 1 first. So 3 times 2, negative 2 plus 1 is leaving with an exponent of negative 1, minus 4. So we're noticing now we have a negative exponent, so we're going to have to do some movement down into the denominator, because remember that we're thinking about this as being a fraction of over 1. So I'm going to open up my set of parentheses here. So I'm going to still keep this as 3 times. But when I move this down, that's going to become 1 over 2 to the positive 1 power minus 4. And just be careful of your fraction work here. Since I want to do the stuff on the inside of my set of parentheses, I'm going to put that 3 over 1. And I'm going to go ahead and evaluate that 2 to the positive 1, which leaves you with a 1 over 2 minus 4. I'm going to still combine these on the inside first. So 3 times 1 in the numerator leaves me with a 3. 1 times 2 in the denominator leaves me with a 2. And then I want to go ahead and subtract 4. But I know that since I'm working with a fraction here, I'm going to keep this 4 over 1. And in order to subtract these, I need a common denominator. So it looks like my common denominator would be 2. So I'll multiply my second fraction here by 2. So that will give me 3 over 2 minus 8 over 2, which leaves me with a final fraction. If I subtract across the numerator, 3 minus 8 is negative 5. Leave the denominator of 2. It's a little bit more work, but it's doable. Just, again, make sure that you're kind of keeping your work organized here. If you have to put things over 1 to add or subtract, go ahead and do that. All right, we'll do the last one, then I'll have you guys try that last problem down at the bottom. So 3 times 2 to the negative 3 plus 1 minus 4. So 3 times 2 to the negative 3 plus 1 is negative 2. And then I'll pull over that negative 4. Again, I'm noticing I've got a negative exponent here, so I'm going to need to probably do a little bit more work like I did in the last one. So I'll make this in parentheses 3 times. And again, we're kind of thinking about this fraction as being over 1, so I'm going to pull that down to make it a positive. So 1 over 2 to the positive 2, close my parentheses, minus 4. So I'm going to kind of organize my work here again, put the 3 over 1, and I'm going to simplify this 1 over 2 squared. So that leaves me with 1 over 4 minus 4. So if I simplify in the fraction, 3 times 1 in the numerator gives me a 3. 1 times 4 in the denominator gives me a 4. Again, I need to subtract out this 4, but since I'm doing subtraction, I'm going to put this as 4 over 1. And I'm going to need a common denominator. So between 4 and 1, my common denominator would be 4. So I'll multiply the second fraction by 4 here. This will leave me with 3 over 4 minus 4 times 4 is 16 over 4. So when I do my fraction subtraction, 3 minus 16 leaves me with negative 13 over 4. So then here comes the fun part of filling in the table. Well, now it's telling us that our function was actually 3 times 2 to the x plus 1 minus 4. So what is x? Well, x is all of these values down here. So in the first column with the negative 3, that's telling us to do 3 times 2 to the negative 3 plus 1 minus 4. Well, that was the last problem that we filled in over here. 3 times 2 to the negative 3 plus 1 minus 4. We said that was negative 13 over 4. Next problem is telling us our x value is negative 2. So 3 times 2 to the negative 2 plus 1 minus 4. That was the problem we did just before that. So we said that was negative 5 over 2. So 3 times 2 to the negative 1 plus 1 minus 4. That was this one up here. We said that was negative 1. 3 times 2 to the 0 plus 1 minus 4 was this one up here. We said that was 2. 3 times 2 to the 1 plus 1 minus 4 was the problem we did up here. We said that was 8. 3 times 2 to the 2 plus 1 minus 4 was the problem we did right here. That was 20. And then 3 times 2 to the 3 plus 1 minus 4 was the problem we did up here, and that was 44. So here's our table of values for that last example. So go ahead and pause the video, try the last example, and thanks for listening.